All right, everybody, welcome once again to the ESAB Weld-On series here for part of National Welding Month and the ESAB University video series. I'm Ian Johnson, once again coming to you from the Big Tire Garage. And oh, hold on, I gotta once again just remind you, if I look over there, I got my live stream monitor over there so I can see what I'm doing. So I forgot to put the little logo up. Hold on. Bam! There it is, right there. Whew, I guess the right size this time. Okay, so here we are. So today, a couple things. Today is the Welding Power Hour. That's what we're calling it. So we're going to start off with myself here in my shop, Big Tire Garage, coming to you live. And then what's going to happen is we're going to kick over to the internationally acclaimed, world-famous celebrity welder Bob Moffat is going to kick on right after me, and he's going to teach a class. You're getting two for the price of one today, even though it's free. So 2 for 1. So first of all, a little bit of housekeeping. Today is a big day because here is the deal. This is the end of National Welding Month. Your friends at ESAB Welding and Cutting are going to be giving away today's big prize, which is the brand new Mini-Arc Rogue 180i and a Savage hood. Now, the way it's going to work is the entry form will be pinned in a comment in the comment section in the Facebook post. So you'll see the entry there. Click, go there, enter to win that new machine and that new helmet. So today's lesson. Okay, we asked you guys what you wanted to talk about this time, and a whole bunch of you were very adamant about you wanted to know about welding some stainless steel exhaust. So what I have here is I have a piece of stainless steel exhaust on the bench, a couple of cuts right here. I've got my TIG torch and all the stuff I need to weld with. First of all, PPE, same as always. We're going to be TIG welding this, so we're going to have our thinner gloves. We're going to have obviously our welding helmet, which I put back here by mistake. Obviously we have welding helmet, long sleeves, all that kind of stuff. One other piece of PPE that you should also be aware of is, for what we're doing today, it's not necessary because I'm just going to be doing some small little demo beads here. But if I was working on a complete stainless exhaust system for a project, I would get it to the point where it was simply tacked together, maybe held in place with some big beefy tacks. And then before I fully weld that piece of stainless exhaust out, I am going to put on some type of respirator or fresh air system. And that is because twofold. Number one, when I'm welding with stainless, I'm right up on it because we'll talk about that when we talk about bead profile on stainless. So you're right up on the material, a lot closer than you are even if you're MIG welding stainless or even when I'm just working underneath the car, tacking it together, or truck. So I'm going to be a lot closer. The stainless, depending on the manufacturer, can have a large amount of chromium in it, which is going to off-gas as we weld. So when it comes to the point of finish welding out a complete exhaust system, that is when I definitely put on fresh air hood or some type of respirator to wear while I do all of the welding. So let's start off right at the beginning with the material. So we're dealing with today, everything we talk about today is going to be specific to stainless steel exhaust, and in particular, just basically the kits that you're going to buy if you buy them from an aftermarket supplier. This particular piece and pieces that I have here are from MagnaFlow exhaust products. And when it comes to buying the exhaust material for your project, this is just like everything else. If you're throwing an exhaust on your mom's minivan or just some, daily driver everyday car that you just need to get exhaust on, don't waste your money on stainless. Go get some aluminized pipe, grind the aluminized coating off of it, and just MIG weld that sucker together. That is going to be a better use of money and your time. Stainless is fairly expensive, and it is an investment. It is a high quality exhaust because you are usually, when you buy a good piece of stainless like this, it's going to be mandrel bent, so it's going to have nice smooth bends. Even if a tight U bend like this, you can see that is incredibly smooth radius on that U bend, and that is what you're after when you're building an aftermarket exhaust, where you're trying to basically get as much flow out of your exhaust and the best appearance out of the exhaust. So choose some good quality stainless exhaust pipe. Don't just go to the lowest common denominator. Oh, that's the cheapest pipe. That's what I'm going to buy. So that's the choice of the material. Now we're going to talk about cutting it. Now there's lots of different ways, obviously, to cut exhaust pipe or any type of steel. And one very popular way to cut it is to use one of these bad boys right here. Let me just merge this over here, get it set up right. So this is the standard everyday abrasive chop saw is what I'm going to show you right now. So this is the standard abrasive chop saw. Probably what you're going to see in a lot of shops. The reason that I don't like using that to cut the stainless has to do with what it does to the material after the cut. You can see that while we were cutting that, there's a lot of sparks and a lot of heat introduced into the material. And I can actually show you right here on our little desk cam here. This is the actual piece that was cut. See if it'll focus on it. So you can see on this side, it looks pretty good, it's no big deal. But when you roll around to the opposite side where the big burr is from the cut, I'm trying to find it with my hand here. Oh, wait, sorry. I'm showing you the wrong piece of pipe. There we go. So you can see on this side, see that little brown edge that is basically popping up into this pipe? And as we roll around to the back side, it's going to become even more evident on this. You can see that that has actually started to boil some of the chromium out of this particular pipe. Now, why that is bad is because that's going to affect when we weld it together. That's going to cause some impurities in the weld. It's going to cause some a not very good looking weld. What's going to have those impurities will boil up to the surface, and that can quite often cause that weld to gray out prematurely. And graying out on a stainless weld, especially when we're talking about exhaust, that's going to do two things. Number one, that means that there's lots of reasons why it grays out, but that's basically the chromium boiling out. It's a little less, there's some structural issues there, not so much when we're talking about exhaust. It's more of an appearance issue. So the way that I prefer to cut this particular exhaust pipe is with one of these bad boys right here. Let me just get this all set up here, right? Okay, so this is, so this is this thing I got on my bench right here. This is basically a vertical bandsaw-ish kind of thing. It's a portaband, which then gets mounted onto a stand, and it basically turns it into a small upright bandsaw. One thing I want to point out, let me fast forward a little bit here. I flipped it around here. There we go. What you want to do is roll the pipe through the cut. You're not trying to cut through the actual pipe. You want to just try to cut one side at a time. So you can see how I'm actually rolling that pipe as it goes through. I'm not just trying to chop through the whole piece of pipe in one shot. By rolling that pipe through the bandsaw, it helps you with a nice straight cut. If you're having issues with getting a straight cut, our old friend, we talked about this last time, painter's tape, get it at the dollar store, it's great. Basically wrap painter's tape around it and use that as your guideline. And when you wrap the tape around, you can actually tell if your tape is crooked, because when you get to the opposite side, it won't line up correctly. You'll see that it'll be coming off of the edge. So then unwrap it and wrap it again. Everything about stainless exhaust is just like everything else when you're talking about a really, really high quality TIG weld. It's just time. There's going to be time that needs to be spent. Time needs to be spent when sourcing the right material. Time needs to be spent when cutting it. So that's why I use this bad boy right here, this little portaband. You can get this online. It fits a bunch of different portabands. This one's the Milwaukee one. And basically, and the best part is you can pop the portaband out of here. It's not going to live in here. You can loosen it off and take it out if you have to. So that's cutting. Now let's talk a little bit about grinding. So even though your stainless is going to show up and it's probably going to look like this, it's going to be fairly pretty, there's still going to be maybe a little bit of oil or something material on there. You want to worry about that. Maybe you've cut it, and even though you've cut it on the portaband, there's going to be maybe a little bit of a burr on the edge, and that's just normal. The last thing that you want to do, in my opinion, is grab your flap wheel with a grinder and start grinding on the edge of this piece of pipe. The reason why is exhaust is not very thick, and if you take the flap wheel and start grinding away on this edge, number one, it's not needed. You don't have to do it. Number two, you're introducing heat into that stainless, which you don't want to do, and you're actually making it a lot thinner. And we don't want to do that because we're trying to prevent any type of edge blowout when we perform basically a butt weld on the joint, which is one of the most popular ways to weld your stainless steel pipe together. So instead of grinding, what I like to do is I just like to take either a little bit of Scotch-Brite or maybe this is 120 sandpaper and just grab it and just use it to basically take that burr off on the outside of the pipe, put a little bit on the inside. You want to be careful though when you do this. Make sure that you're not putting a lot of pressure on there with your finger, because if there is a sharp burr, you actually can cut right through that sandpaper and cut into your hand. So what I normally do is I'll just take it in here like this, and I'll just don't put a lot of pressure on it, just let the sandpaper do its job, and then I'm just going to go all the way around, remove the burr. Another thing you can do with the sandpaper is you can actually set it right on your workbench. Hold on, I got to get back to my correct camera here. Bloop, bloop. You can set it right on the workbench, and you can just work the pipe back and forth like this, and that's going to help give you a nice flat surface to weld to. You can see, even though this is just 120 sandpaper, it's obviously removing some material from the pipe, and that is because the stainless steel pipe, although stainless steel is very hard, it's not hard like mild steel, like a piece of 120 wall mild steel. By using the bench like that on a piece of sandpaper and just sanding it, you're going to end up with a nice flat surface to work from. So, talked about grinding, prep. Once again, we talked about prep last time. You know, you've got a couple options. You can use easy wipes. You can use some acetone on a piece of paper towel or a red rag. You can see here just this amount of grime literally just came off these two pieces of pipe that are out of a brand new box. And that is because when the manufacturers process this pipe through their facility, whether they're bending it, rolling it, cutting it, it's going to have some type of lubrication on it for the machines to do their work. They can't just run the stainless through those machines, especially through a bender, without some type of lubrication. So there's going to be some type of light oil on this pipe when you first get it. So the best thing to do is give it a wipe down before you are going to weld. Now, let's talk about welding, because that's what we're here for. So we've sourced good material, we've cut it, we've prepped it, we've got it ready to go, and now it's time to glue it all together and build your exhaust system. Well, first thing you got to decide is how you're going to weld it. Yes, you can get stainless steel filler wire for the MIG, and you can run it through your MIG and basically stainless exhaust with the MIG. I've never done that personally. I've never felt the need to, the expense of actually getting that roll of wire, because I normally just go ahead and TIG weld anytime I'm dealing with the stainless exhaust. But some of the things that I do make sure that I do while I TIG weld the stainless exhaust is, set this up so you can see it very good here. Okay, so these are two pieces of tungsten. Let's see if it'll focus on this one. So that is a pretty standard angle. Come on, focus, focus, focus. It's trying to focus, I know it is. So you can see right here, that's a pretty standard angle that I would run on tungsten whenever I'm just working with mild steel in the shop. So this is about a 30-degree grind on this piece of 3/32 tungsten. When it comes time to weld stainless, I will go to a much sharper tip. So this is an 18-degree grind, and then I'll just blunt the end of it down. So this is 18 degrees on 3/32 tungsten, and this basically allows me to get that arc really, really fine-tuned, because when you're working with stainless, the most important thing that comes up is arc length. We've all seen the stainless welds where you get that little rainbow look. Now, if we're talking about professional stainless and comparing it to, you know, like a maybe some food grade stainless or something like that, you'll often see they'll actually acid etch that off, because that rainbow look is actually, it's some of the material in the stainless boiling up to the top. Those of us in the hot rod world, ooh, we like that rainbow look because it looks cool. So to obtain the rainbow look, you have to do a couple of things. Number one, we're going to ensure that we have a proper amount of gas coverage. And then number two, we're going to ensure that we have a very short arc length. So that means that we need to get the tungsten as close to the material as we can. You'll often see, when you're doing it, you can sometimes actually see the tungsten basically just lick the puddle of the weld while we're welding it. Now I'm going to try and move this a little bit closer, see if I can get this thing to agree with me. There we go. Come on, there we go. Okay, so what I'm going to do is I'm going to strike a little arc here, and we're going to see how it looks through our little desk cam there. So, one other thing I want to talk about, I talked about gas coverage. On this particular weld, what I am using, once again, is I'm using my Rebel 205 AC/DC. I have it set on DC TIG, obviously. I believe I've got it set at about 75 to 80 amps. I'll double check it in a minute. And then I am running the oversized, let me merge this over, boop. I am running an oversized ceramic cup. This is a FUPA cup. And I think this is a number 12. Yeah, this is a FUPA 12. And you can see the reason that I run that is twofold. Number one, I could just run like an Arc Zone Monster cup, which is what this cup here is. Let me just see if I can get that in there. So this is a similar size cup. This is a Arc Zone Monster cup. It's just a larger cup. You can see that there's a little bit of extra diffusion in there as well. But the reason that I like running the ceramic cup, especially when doing stainless, is so I can get a really good look, especially when working with tubing, because quite often as you're working, it's going to be sometimes hard to see exactly where you are on the joint as you're working your way around. So having that ceramic cup on there allows me good visibility no matter where the torch is. So step one, I'm going to turn on the machine. Make sure the gas is on. That's important. Okay. Oops, I should have put my tungsten in. That's my bad. There we go. Okay. Now, one other thing that I want to talk about is I'm at 76 amps on this machine. Just like everything else that we've talked about before, when it comes time to start welding, you don't just grab the TIG torch or the MIG gun or whatever you're going to weld and just have at it on the finished product. If you're working with stainless exhaust, get yourself a piece of scrap stainless or a piece, and make sure it's the same material that you've built the rest of your exhaust out of. Same manufacturer, same thickness, same everything, because you're going to basically be fine-tuning both the welder and the arc length as you work. You just want to run a couple of test beads on this material. So, next thing I want to talk about is seeing the arc. When it comes to welding stuff like this stainless, I'll step up. I've mentioned it before about wearing a set of cheater glasses. So cheater glasses are just some reading glasses that allow you to get a little bit closer, almost like a magnifying glass on the weld. You can get little cheaters for the helmet. I actually like to have the glasses because I find then when I move my head around, I'm not sort of losing the view through the cheater lens inside the helmet. When I'm working with stainless like this, I will up the magnification on these cheaters. That way I can get really, really fine-tuned in on that arc. And this is, like I've said before, this is just something where it's trial and error. Try a bunch of different ones and see which ones work best for you. So let's see here. We're going to merge this over. So all I want to do is get my torch in position. Check to make sure my gas is flowing, which it is. All right, get my torch into position. And the key here is make sure I'm in a good spot where you guys can see what's going on. Yep. I want to make sure I have a good, close arc length. So I can reach down, I'm just going to touch it. So I know that's touched. Pull it off a little bit. And most important, we are not moving the TIG torch after we weld. We're ensuring that the gas is flowing out of the cup and covering the weld. And then after we've done a little test weld like that, we're just going to take a quick look at it. Don't necessarily need a 4 on for that. I'm going to take a quick look at it and see what it looks like. And what we're looking for is, we're trying to decide, this little test bead, was it too hot? Was my arc length too far away? What happened to the stainless? And on this one, I'll see if I can get you over here. So you can see on this one, it's hard to tell on this webcam, but I have a fairly decent color to it. It's not grayed out or burned out in any way. It may be a little too hot for this particular piece. So I'm going to pull a little bit of amperage out of it. All right. And then I'll run another bead and see what it looks like then. Get this set up so we can see it good. Okay. Now what I'm doing right now, these are basically, I'm just sort of like practicing what would be considered a fusion weld. So this is no filler. I'm just basically trying to run a little fusion bead right on the material. So again, not moving the torch. As you can see here, to me, it's hard to tell through this camera lens, but I feel like the second bead is a little less grayed out, and therefore I think that I'm a little bit happier with the amperage setting on my machine. So that's the first step in checking it. If it was grayed out, there's a couple things that it could be. It could be it's either too hot. When that machine's on, I tend to yell at you guys. If the stainless grays out, it can be because it's too hot. It can be from inadequate gas coverage, or it can be improper arc length. So I knew my arc length was okay because I could see it. I was obviously incredibly close. And I knew my gas coverage was okay because I'm using the extra large FUPA cup. And so I don't feel that it's gas coverage. So when I feel that it was just a little bit gray, what I did is I just dialed back, pulled about 10 amps out of that particular weld, and I'm a lot happier with it. So that's the first step in just sort of choosing your machine, setting it up. You can go by sort of the rule of thumb where you measure the material. It's 1 amp per thousandth of an inch. But with stainless, I kind of like to get in there even after that and still fine tune it just a little bit to play around with it a little bit. So now let's talk about a fusion weld versus basically a weld using filler material. Very often when it comes to stainless exhausts, you'll see most guys do just a pure, guys and girls, people, do a straight fusion weld on any type of joint. I'm going to try and set this up here so we can all see it together. Let's see here. So what I have right here is basically got a piece of, oh, that'll work. There we go. So what I've got is a piece of exhaust here that, let's just say this is the joint here. I'm trying to get this set up. Come on, little camera. There we go. So what I have right here, oh dear. I'll just let it lay down like that. So what I have right here is an exhaust, piece of exhaust with a pretty common setup right here. We basically have this would be a piece of pipe attached to a second piece of pipe right there, and we would be basically fusing this joint together. Now, a very common way that people would do that is they perform a fusion weld, which is basically just gluing the two pieces together, no filler material at all. So let's just take a look at that. Now, what gets tricky about these fusion welds is the fact that we're working with 2 pieces of edge material right here. So there's a very good chance for burn back or blow through on one piece or the other, which is why arc length and amperage control is really, really important here. Now, what I normally do on a piece of stainless like this is I start with very little pedal input at all and then work from there if I'm trying to get the weld started. So I basically strike the arc. See, I got a tiny little flashlight arc there. And then once I get them joined together, then I'm going to just I'm basically what I like to call wiggle foot welding this. So when I move it, I give it a little bit of gas, then I let off, a little bit of gas, let off, a little bit of gas, let off. Then stop. Do not move the cup. Okay. So, oh, I'm on the back side. You can't even see that. I'll move the camera here so you can see what I'm doing here. Hold on. So I was doing what's basically referred to, it's kind of like a self-pulse, I guess. I call it wiggle foot welding. But what I'm doing is I'm depressing the foot pedal to increase the amperage, and when that happens, that's when I move the torch. And then when I see what's called the keyhole, which is the basically it opening up, I'll start to see it burn back. I'll back off on the throttle, and then you'll see the keyhole close up, and then you can see what's going on. But right there you can see that is, come on, focus, little camera. Focus on the weld. There you go. You can see that's what a fusion TIG weld is going to look like right there. So, oh wait, I'm on the wrong camera. There you go. So come on, camera, focus for me, please. There we go. So you can see right there, that is a fusion TIG weld. You can sort of see the little starts and stops where I was basically wiggle foot welding that across the 2 pieces of pipe. You can see the brown out here on the edges, and that brown, I believe, is caused because of the fact that I did not back purge this particular joint. Now, I didn't do that because I'm just here teaching this lesson here quickly. But if I was going to weld this particular piece of exhaust pipe, and this was my final weld, before I performed my final weld out on it, I would want to back purge the exhaust. Now, there's a couple of ways that you can back purge. If you're a professional welder and you do a lot of stainless steel welding, a lot of pipe welding, they make back purge kits, which are little plugs that fit in either end of the pipe. If you don't have access to that, another way to do it, honestly, is once again, the magical blue tape. So here's what you do if you're going to back purge. Basically, all you're going to make sure it's not hot. Move it down here so we can see it. Actually, I'm going to move it. I don't want it to fall off. There we go. You know what? We'll do this end. Move it over there. Right here. Okay. There we go. So, if I was back purging this, oops, wrong spot. I don't want to zoom, I want to merge it. So, what we would do is we would get a secondary regulator, and we just take the hose off the back of the machine that it is feeding. This is pure argon. We would just feed it into the pipe, and we would take some of our magical blue tape, and then all we're going to do is basically cover it all up with our tape, making sure that we'd sealed it up the best that we could, and making sure that there's nowhere for that argon to escape out of this end of it. There we go. Then what we would do is we would tape up the opposite end and then poke a couple holes in that end, because what that's going to do is as the argon flows through the pipe, it's going to push all the oxygen out of the opposite end of the pipe, and then you will have it back purged. Now, there's 2 ways to do this. What I have here is honestly another argon bottle on another welder, just sitting right, it's not in the screen, right there, you can't see it. Another argon bottle right there, I would set the flow very low and basically just push that argon through, and I would just turn it on and then start welding. But there is another item that you can get, and it's this bad boy. So this, you can get what's basically called a dual flow regulator. So this goes on to the argon tank and it has two outputs. One output is going to feed your welder, and the second output is going to go out and it is going to feed your backflow hose. And that way you don't need to get a second bottle of argon. You can work off just that one bottle. I've seen those online sell for $50, $60. You can get them. And if you're going to do a lot of stainless exhaust, it's definitely a good investment. Okay, so we looked at fusion welds. So fusion weld would be the very popular way to weld this exhaust system together, but I sometimes prefer to use actual filler even when doing these stainless exhausts. The fusion weld is probably the most common way that you're going to see this exhaust be put together, and that is because with good proper fit up, which you want obviously because you're looking for good appearance as well as good performance. Good proper fit up, you should be able to fusion weld that joint all the way around. What I like to do is I like to add filler, and the reason I like to add filler has to do with finishing out the exhaust. If you fusion weld it, what tends to happen is you end up like with a little concave, little valley where the weld is. So because of that, when you try to fit, if you Scotch-Brite the exhaust, you end up with these little sort of valleys. They just don't look as good to me. So I like to go ahead and just use filler material. And the most common filler material out there is some of this stuff right here. Doop, 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 doop. So this is some 308L. This is obviously ESAB brand filler. There's a 308L, and this is a 1/16 of an inch, very, very small, because you don't want to be trying to melt the filler, really thick filler when you're dealing with really, really thin exhaust. And I've gone ahead and I've run a couple of test beads here, and you can sort of see. So this, let me get this, oops, let me get the camera set up here. Okay. So get rid of my purge hose. Don't need it because we're not actually going to purge that. We just did that for show. So you can see here. Trying to get this to focus on it. There we go. So, oops, my mouse is not in the right spot. So this was just a little test bead I did with some 308 filler. You can see I was just sort of setting up the machine. I just ran a couple of beads down the exhaust pipes. This is some 308, and then I adjusted a little bit down here. And this is actually some 309 that I was running down here just to see what the different characteristics were. Just like when you're setting your machine with the arc length and all that kind of stuff, when you're working with your filler material, make sure that you test out what works best for the exhaust system that you've bought, because even though this exhaust is stainless steel exhaust is coming from a reputable supplier and it's coming to you and you're very certain that it's high quality stainless, the reality is you know, there's no real rules about what gets delivered to you for your stainless exhaust, not to the same rules that would apply to food industry or medical grade stainless. So sometimes it's best to run a couple of test beads on the stainless just to see which filler material works best. 308 is obviously the most common. 309 is normally used when you are welding two dissimilar materials together, so like a mild steel and a stainless steel, and you're joining them together. I've had cases where I've gotten some stainless that was slightly questionable about the quality of the stainless, and the actual weld appeared better using 309, so that was what I ended up welding it with. I've also had instances where I've had to make my own filler, and so what I do is I cut strips out of the pipe and then flatten them out, and that's when I don't really know what kind of stainless I'm dealing with, and no matter what I try, it's graying out or it's washing out or it's burning back really easy. What I'll often do is I'll just go ahead and just cut up some of the material, flatten it out the best I can, and kind of use it as the filler the best I can. But then I just don't use that material anymore. Okay, so those are our back purge, fusion weld, and then weld with filler. Let's talk a little bit about the most common problems. So let's just start with arc length. So let me set up my little camera here so see if I can get this up in the air again. Get this thing so we can see some. See if we can get the arc length to walk out on this bad boy. Okay, so probably it's the most common mistake I see people make when welding with stainless is they either go too much heat or too much arc length, especially when dealing with tubing, because as you're working your way around the tube, it can get hard to maintain the proper arc position because of what happens. So I'll show you here. So if this was our joint was right here, let's just say it was right here, it gets difficult because as you're working the torch up, it's very easy just to work your way down the line, and instead of rolling the torch around the steel, it's quite easy just to sort of let it roll back in your hand, and then you'll end up with an incredibly long arc length. I'm just going to show you what happens when you do that. So when you get that long arc length, that's when you start to lose your gas coverage, and you're also going to lose your proximity to the piece of material, and that's going to cause problems. So if we come in here like this, okay, we get her set up, and we're just going to roll up this joint this way. So, oops, lost my ground for a second there. There we go. So I'm rolling the torch around the tube as I go to try to ensure that I have a good arc length as I work my way across the tube. You can see my torch position here versus how it started. So now what happens if I just come up? So now let's do it this way. So now if I don't roll the torch, you can see the arc length is starting to get pretty far away. You can even just see it, how it's glowing red. And you can definitely see the difference between the two. Come on. It wants to focus. There we go. You can definitely see the difference. So this one right here is working to maintain that proper torch proper torch position by rolling my wrist around the tube and keeping that arc length good and tight. This one on the back side, I just basically let the torch go up. You can see it still welded it, but the arc length was so long that the stainless has completely grayed out. Now the reason it has completely grayed out is because I've put so much heat into that piece of stainless. I could actually see it when it was all said and done. I could actually see how red that stainless steel was. And when you see that stainless go super red like that, that's way too hot. At that point, you have boiled the chromium out of that piece of stainless. If your end goal was to possibly polish this or do something to it, you're not going to end up with the look that you are after. So that's the most important thing, is just you got to practice that arc length, practice that gas coverage, try different filler materials on your piece of stainless exhaust before you start doing the finish weld, and just spend some time practicing, especially different torch positions. Try different types, different amounts of cheaters, try different angles on your tungsten, try different size cups, and just work your way around it. One more thing I can say, especially about stainless, don't rush it. Take your time. It's not this is not a speed job when it comes to especially welding out a complete stainless steel exhaust. This is something that you want to take a little bit of time with, ensure that you're not putting too much heat into the finished product so you're not causing issues with it, and just work your way through it. That way you'll end up with a good quality weld and a good looking weld. So there you go, guys. That's basically stainless exhaust sort of 101. I'm going to jump on over here to the old Facebook page just to see what's going on over there. See if anyone's got lots of comments. There is an ESAB rep on there. I should have said that, answering questions. I'm just going to scroll through here, see if there's anything that I need to answer. Once again, what I will probably do is I will come on and I will look through here and I will look for any questions that sort of jump out at me, or if people okay, here's one that we can just cover quickly. Christopher Dale Moore wants to know what is the difference in strength between fusion versus using filler rod. Using the filler rod is obviously going to give you a lot stronger joint because you are actually adding material to the molten puddle and therefore adding material back to the joint instead of just letting it sort of melt back together. When it comes to an exhaust system, that is not as critical because the exhaust itself, especially the joints in the exhaust, aren't really what we would call load bearing. You have to remember, like from a factory, the exhaust is just like a slip fit with a muffler clamp on it. The exhaust is hung by hangers and different other items to take the weight of the exhaust. So essentially all you're doing is preventing the exhaust leak. So is it critical to have to ensure that you use filler at the joint on an exhaust system? No. But is it stronger if you use filler? Yes, absolutely it is. The problem that people run into a lot of the time when they're adding that filler is they missize that filler because they'll just get like a large filler and they end up putting so much heat into the exhaust that they end up boiling the chromium out because they're trying to weld basically both pieces of stainless and the filler at the same time. So that's why you'll see most people just stick with a fusion weld when they can. Fusion weld is really, really good when dealing with headers because it's so small of an area that you're working with as well. So there we go. I want that carbon fiber dip Sentinel. Nope, sorry, it's mine. Okay, so there we go. I'm just going to keep scrolling down here. If there's any questions. Jake, yeah, I'm working on. All right, guys. So as I said before, what I will do is. Oh, Zach Rice, very good point. I did not mention that I was using a foot pedal. I think I mentioned it earlier. When I'm welding stainless exhaust, yes, 100%, I am going to want a foot pedal. And the reason why is just puddle control. Because quite often I'm dealing with these butt joints where I'm working on two pieces of the edge and I am working with a really, really small arc. I want to be able to ensure that I don't blow through. You are right on the edge of blowing through on these butt joints all day long. So by not being able to control and fine tune that amperage output on the tungsten, there is a greater chance. With the scratch start, it can be done. What I would do if I didn't have foot pedal, I would set the amperage very low. I would run a bunch of tests and find out what the minimum amperage I could run. It would be incredibly slow welding because I would want to make sure that I'm not adding too much heat. So something like this, I may roll it back down to like maybe 40 amps, 35, 40 amps. And I would also weld it in stages. So I would do maybe an inch, let it cool, reposition, maybe go to the opposite side, do an inch on that side, go back and forth. I would not try and run all the way around the stainless pipe without the ability to have a foot control. Just because without that foot control, the minute that this blows out, it blows out like that and both edges tear off and then you just end up with a big hole and then you're chasing that hole. So there you go, guys. Once again, thank you so much for watching the ESAB National Welding Month Weld-On series with myself, Ian Johnson from here in the Big Tire Garage, and the internationally acclaimed and incredibly handsome Bob Moffett. So Bob Moffett is going to come on right after I have left here. So make sure you stay on the page. I think he's going to pop in here in maybe 10, 15 minutes. Thank you once again. Congratulations to everyone who has won a Savage hood this month. And congratulations to whoever our winner is today for the lucky contest. So once again, thank you very much, guys. And we will see you next time here in the Big Tire Garage.